All right, so here's another example of word problems from chapter 5. We're going to do, out of section 5.1, we're going to do number 71 right here. John and Mary leave their house at the same time and drive in opposite directions. John drives 60 miles per hour and travels 35 miles faster than Mary, who drives 40 miles per hour. Mary's trip takes 15 minutes longer than John's. Find the length of time that each one of them drive. So we have two variables, and one thing we talk about in class is the question is the variable is the question. So as I set up the solution, I would say x equals John's travel time, and we're going to let y equal Mary's travel time. And so with these two variables, I can set up a 2x3 table to organize rate times time equals distance. And let's see, we have John and Mary. And for free, they're going to give us that John's going 60 miles per hour and Mary's going 40 miles per hour. I have x and y for those times. Those are our knowns. And so then 60x and 40y would be those distances. And so this is where we have to be a little bit thoughtful. It says John, let's see, John goes 35 miles per hour longer. So what that means then is if I take 60x, which is John's distance, that's going to equal Mary's distance plus 35. So I'll repeat that. Let's see, it says John travels 35 miles further or farther than Mary. So if I add 35 miles to Mary's distance, they should be the same. And then we read that section again. It says Mary's trip takes 15 miles longer. So what that means is if I set x, which is John's time, then I should have y, which is Mary's time, minus the 1/4 of an hour. So over here I'm thinking 15 minutes equals 1/4 of an hour. We have to keep those units the same. So repeating that, let's see, x represents John's time, and so since Mary goes longer, we have to subtract 15 minutes from her time for these to be equal. And so this gives us a system that sets up perfectly for substitution. I'm going to replace, let's see, I'm going to isolate the y here. I think that's going to be an easier approach. And when I do that, you might recognize this is another way of thinking about this. We're saying that Mary's time is equal to 1/4 of an hour plus John's time, which makes sense because that's 15 minutes longer. So I'll take this expression and plug it into the y. So that gives me 60x equals 40 times x plus 1/4 plus the 35. So this is our substitution process. We will distribute and solve for x. So solving for x, I get x is 2.5. So that's hours. So John's time is 2.5 hours. And then we know this. We know Mary's time is going to be a 1/4 of an hour less. That's not 2.5. That's 2.25. Checking my calculation. So John's time is 2 hours and 15 minutes. And then Mary's time is going to be 2 hours and 25 minutes plus the 1/4, plus the 0.25. So that's 2.5 hours. So here are the two times that John and Mary both travel.